Let us solve a question on constrained optimization of a production function subject to the cost constraint. The question is, let the production function be, that is, output is a function of two inputs, labor and a capital, which is equal to under root of L square plus K square here. Price of labor and capital per unit are $30 and $40 respectively, and total cost is equal to $580. We need to find out the maximum value of output that can be produced subject to the cost constraint. Okay, so this question is output maximization. That means we want to maximize our output. We want to maximize our output, which is equal to under root L square plus K square, and I can write it like this: L square plus K square, and in place of under root sign I will write 1 upon 2. So we want to maximize output subject to the cost constraint that the producer will be facing, that is the price of labor times units of labor plus price of capital times units of capital should be equal to the total cost of the producer. Specifically here, price of labor is $30, so we can write 30 L plus price of capital is 40 times K, and total cost is 580. Simplifying further, dividing both sides by 10, we will get 3L plus 4K is equal to 58. Okay, so this is our question. Now, how do we optimize this function? So graphically, it means if I draw a simple graph to make things more simpler, we have labor and capital on horizontal and vertical axes. With the given cost constraint, let us suppose this is our cost constraint. Okay, the producer's aim to is maximize its output, that is, he wants to reach to the highest possible ISO count, and the maximum value of output will be at a point where the ISO count and ISO cost lines are tangent to each other. Okay, and it happens at this point where ISO count and ISO cost lines are tangent to each other. Now at this point, what condition is satisfied? So for maximization, so this relation should be held, that is, marginal rate of technical substitution between labor and capital should be equal to the input factor ratios, that is, or rather the input price ratios, price of labor upon price of capital. Okay, now this denotes the slope of ISO count, and this denotes the slope of our cost constraint. Okay, cost constraint here. So marginal rate of technical substitution is, we know it is the ratio of the marginal product of labor and marginal product of capital. It should be equal to the ratio of the prices. We have 30 upon 40, which is equal to 3 upon 4. Now let's first find out the marginal product of labor. Marginal product of labor, as we know, it is the change in the output due to the change in the units of labor employed, and marginal product of capital, it is the change in the output due to the change in the units of capital employed. Okay, which implies, so MPL is the partial derivative of production function with respect to L, MPK is the partial derivative of production function with respect to K. Now let's take the partials with respect to L first. Using power function rule, exponent becomes coefficient first, so we have 1 upon 2, then we have L square plus K square, and exponent is subtracted by 1 by power function rule, we will get negative 1 upon 2 times, we apply the chain rule, the derivative of L square is 2L. Okay, likewise MPK will be the partial derivative of this function with respect to K. Again, using power function rule, exponent becomes coefficient, we have L square plus K square, and exponent is subtracted by 1, so you will get negative 1 upon 2 times the derivative of K square, which is 2K. It should be equal to 3 upon 4. So doing some cancellation here, with this 2 gets cancelled, so L upon K is equal to 3 upon 4, or 4L is equal to 3K, or L is equal to 3 upon 4K. Using this relation, and we plug this value into the cost constraint, in this cost constraint, so we'll get we have 3 times the value of L is 3 upon 4, 3 upon 4K, plus we have 4K, it should be equal to 58. So solving it further, so we'll get 3 3s are 9K upon 4, so we'll get 9K upon 4 plus 4K is equal to 58. Okay, let me see if I have the space. Let's create some space. So 4 4 are 16, go 25K upon 4 is equal to 58, or K will be equal to 58 into 4 divided by 25, which will be equal to 4 8s are 32, 4 5s are 20, 21, 22, 23 divided by 25. This will be the units of capital employed. Now to find out the units of labor employed, it will be equal to 3 upon 4 times the units of capital employed, which is 232 divided by 25, which will be equal to, okay, let me do some cancellation here. 2 2s are 4, so we will get 3 upon 2, here 2 1s are 2, 2 1s are 2, 2 6s are 12 divided by 25, which is equal to 3 6s are 18, 3 1s are 3, 4, 3 1s are 3 divided by 50. I hope I have done it correctly. So this is the units of labor employed. That means now the maximum output will be equal to, since plug the value of L and K here, so we have L is 348 upon 50 square, plus capital is equal to 232 divided by 25 square. So this will be the total maximum output produced given the given the cost constraint. I hope I make myself clear, and if you find out this video helpful, please subscribe, share the channel with your friends. That is the only motivation for me to make more useful stuff for you people. Okay, keep shining and stay blessed.